So in this study, we're actually extending research that we've been conducting over the last several years for the National Science Foundation. So we've been looking at how we can design virtual reality systems from a user-centered perspective for facilitating motor rehabilitation. There are some standardized psychomotor tests that have been developed for doing diagnostics of motor disability. A typical scenario is that the patient will perform the task and a clinician will observe them performing the task and make observations on the order in which they move objects and their control of objects. So what we decided to do was computerize some of these standardized psychomotor tests and to use virtual reality for collecting data on disabled person behavior in performing the tasks. The other objective that we had was to enhance the VR in terms of attentional cues as well as force feedback for users to try to promote learning rates that would be faster than if they were performing the physical task. What we did was, in a previous study, we actually assessed performance. So we looked at movement of a haptic control. We also looked at the speed of movement. We looked at acceleration and force at the device. And we determined that the VR simulation was comparable to the native task performance. So in this study, we've taken it a step further. And what we're trying to do is, or what we've done is a biometric validation of the simulation. So we've used muscle activation assessment to compare muscle responses in the native task versus the VR task.
In this study, we used the task condition as a grouping variable. We had two groups, VR versus native task condition. Half of the participants was assigned to the VR group. Both of the groups were familiarized with the block design task, and the VR group was trained on the new haptic interface. The computer software captures movement and force data. We use a BioPAC electromyography system to record muscle activation at the forearm. We wanted to determine if the two groups were significantly different. We found the intensity of muscle use to be comparable across the native and VR versions. The pattern of muscle activation with the new haptic interface was comparable to that in handling real blocks. Therefore, the study provided validation of the simulation design.
So for this study, our conclusions were that we can actually use computerized versions of standardized psychomotor tests for doing motor control disability assessment, and we can also use them from a training perspective. And it seems that the VR features, the virtual reality features that we've looked at are actually complementary in terms of accelerating the learning process. The other thing is that, and this is related to industrial engineering, is that we can take these simulations that we've developed and we can actually use them as a platform for training industrial workers in complex assembly operations that would involve fine motor skill. So tasks that are akin to those that we've looked at through the computer-based simulations.